Diabetes is not a modern phenomenon. In fact, a very similar condition was described centuries ago by the ancient Romans, Indians, Arabs and the Greeks. In India it was called madhumeha, meaning honey urine, while in Greece they named it siphon, which is a reference to increased urination, still an important sign of diabetes today. Diabetes is a complex disease which affects multiple organs in our body. Today, it is diagnosed by way of a blood glucose test or by an oral glucose tolerance test. Simply put, diabetes is a term used to describe the body's inability to produce sufficient amounts of insulin. Insulin is a pancreatic hormone and functions as a main glucose regulator. It communicates with our liver as well as our muscle and adipose tissue, or in other words, the nervous system and the gastrointestinal tract, to make sure that our glucose levels are balanced. Both high and low blood glucose levels are dangerous. But what kind of disease is it really, and how dangerous is it? Let us hear from Professor Sir Steve Bloom, head of the Diabetes, Endocrinology and Metabolism Division from Imperial College London at Hammersmith Hospital, who has studied diabetes for more than 30 years.
Diabetes is not producing enough of the hormone insulin, and because of the lack of insulin, we have blood levels of sugar which are too high. Now that high level of sugar in our blood slowly poisons parts of the body, the eyes, the heart, the nerves, and also the blood flow to your feet and your fingers. So this is not a good thing to happen. We do not want our patients to have high blood sugar.
What are the underlying mechanisms that cause diabetes?
The common sort of diabetes, the sort that comes from being overweight, is actually because the insulin isn't working properly and you're not able to produce enough insulin to overcome this, and we give it a name, insulin resistance. And it's that which is the problem. So obesity causes insulin resistance. Your body then tries to make more insulin, isn't able to, and you don't have enough insulin then to overcome this resistance and therefore lower your sugar in the blood. So you wander around with high blood sugar above normal, and that slowly poisons the body.
What stimulates insulin secretion in healthy individuals?
So if I'm a young man and I eat a meal, the food that I've eaten stimulates the pancreas gland in the middle of the tummy to release its insulin, because that's where insulin's made and stored. That insulin then helps the rest of the body pack away the food substances that I have absorbed, sugar, for example. And that's the normal process. So you eat a meal, it stimulates the pancreas gland, you release a lot of insulin, that enables the body to pack away the products of that meal and store it as fat or make you grow. And that's normally what happens, and that's what a healthy person or a healthy animal does.
If I had diabetes, how would it affect my body?
So there are two types of diabetes. One is a consequence of obesity and age, and there you're mostly suffering from resistance to insulin. In other words, the insulin's not able to do its job properly, and you need to secrete much more insulin. And then when you've been like that for perhaps 10 or 20 years, finally the pancreas gland can't cope, and the insulin-producing cells begin to die off. And that's when you have to move from tablet treatment to insulin injections. But that's the obesity type of diabetes that occurs when we get older. There's another sort of diabetes which occurs in youngsters where they have, let's say, a virus infection or something like that, and the beta cells which produce the insulin in the pancreas gland get killed by the virus or get killed by a consequence of an infection called an immune response, and then you have no insulin at all. And we call that actually type 1 diabetes, and it's the original form that we used to know about 100 years ago, before obesity became a problem for our society.
As Steve Bloom said, diabetes is about having too high glucose levels. But how is the blood glucose regulated? Let us now ask Professor Jens Juel Holst from the University of Copenhagen to explain the key aspects involved in maintaining normal blood glucose levels. Tell me more about this.
It's actually a very interesting question, I think. And the problem is that we take in a lot of carbohydrates every day, and I will tell you a little bit about what we do with them afterwards. But the point is that in the body we have a certain compartment, an amount of fluid, that is the fluid surrounding the cells. And that amounts in healthy people to about, let's say, 14 liters or something like that. And in that compartment, the concentration of glucose is about 5 millimoles per liter. That means we have 60 of those little millimoles in that compartment. But when we eat, we can easily take in something like 2,000 or 3,000 of those millimoles every day. And if they were dissolved in those 14 liters, we would have a tremendously high concentration of glucose, which would probably kill all of us very rapidly. Then, on the other hand, there are tissues that use the glucose also at a tremendous speed. The muscles, for instance, can empty that little pool of glucose within minutes. So if you do hard muscular work, the glucose will go away from that little pool and into the muscles where they will be burnt. And then the brain doesn't have any glucose and you'll fall, And that is the problem. So how do we maintain a constant level of glucose? Having too much is dangerous. Having too little is also dangerous. It must be right there in the middle at all times. And that's why we have the liver. The liver is the organ that can take up glucose or put out glucose. And that is regulated by another organ, which is called the pancreas, where we have the islets, small groups of cells. One cell produces insulin that puts glucose down. Another group of cells produces glucagon, which puts up glucose, and they do that via the liver. So we have this little sensing organ that feels, measures the glucose, and sends a message to the liver to either produce or take up glucose. And that's how we survive.
So what happens to the body if you have diabetes then?
See, that's another good question, because there's no doubt that the hyperglycemia of type 2 diabetes, this is what we're talking about right now, is due to an inadequate production of glucose in the liver. Now we can discuss why that is. It's not completely clear. It might be a good thing, because if there wasn't a high concentration of glucose out there, how would the tissues get the glucose to burn? But on the other hand, it's dangerous, because that is what causes all the problems of type 2 diabetes. That is the vascular damage, the neural damage, the organ damage, so that eventually you get all the complications, which really are the threat of type 2 diabetes. So it's a very, very important thing. So again, what makes the liver produce less or too much glucose? So I think one of the key problems here really is insulin. Because insulin normally keeps glucose production in the liver down and uptake in the liver up. But when you have type 2 diabetes, the liver is not as sensitive to insulin as it normally is. And why does that happen? So if you build up lipids, fat in the liver, it becomes insensitive to insulin. And all of a sudden you have a situation where that insulin doesn't work as well as it should. And that means that the liver will, instead of take up glucose, will produce glucose. And that's why you have your high glucose levels. On top of that, there's no doubt that the cells that produce insulin suffer in type 2 diabetes. They cannot produce as much insulin as they should have done. So there's another defect here. So one is you get obese, ruin your liver. 2, you have a genetic defect that hits your insulin cells so that they cannot produce a sufficient amount of insulin. That's the problem.
What is the difference between type 1 and type 2 diabetes?
So type 1 is characterized by an immune attack on the beta cells that kills them. And that means you have fewer and fewer and fewer of the beta cells, and they can produce less and less insulin, and eventually you have a real problem where there's clearly too little insulin. You don't necessarily have to invoke any other mechanism than that. There's too little insulin, and that of course means that you cannot inhibit the liver any longer, that it will produce too much glucose, and that's where you have your hypoglycemia. There's another hormone there, glucagon, that helps somewhat to keep up that glucose production, because also that suffers. That's because of the lack of insulin, probably. But the insulin lack is the primary cause here, whereas with type 2, as we heard already, it's really the combination of a lifestyle that causes accumulation of fat at places where it shouldn't be, for instance in the liver. And then a genetic inability to produce sufficient amounts of insulin to cope with that problem.
As we've heard, regulating blood glucose is a very complex process. What happens within the pancreas, which is the organ that controls the secretion of insulin, is an ongoing discussion, because we do not actually know which exact mechanism causes insulin secretion failure in relation to diabetes. To better understand the cellular mechanisms within the insulin factory, let's ask Professor Steve Bloom to explain what triggers insulin secretion and what can go wrong in relation to diabetes.
The pancreas gland has something called the islets of Langerhans. Langerhans was a German scientist who pointed out there were these little tiny dot-like things in the gland, and these islets of Langerhans, because he described them, are the areas that produce the insulin. So it's these little tiny islets that produce the insulin. They don't just produce insulin, though that's their most important product by quite a margin. That's really critical. If you don't have insulin and you're not treated, you will die. So insulin's really critical. But also these islets produce several other hormones, to give them a few names, glucagon and somatostatin. Now, somatostatin causes growth to stop. Glucagon comes from the word glucose giving, and that acts in the opposite manner to insulin and helps you put up glucose. So if you haven't eaten for a while, you will secrete quite a bit of glucagon from your pancreas, and that'll stop you getting too low a sugar, which people who are starving could easily suffer from.
So whereas high blood glucose affects several of our organs, damages our cells, and may result in blindness, infections, kidney failure, and other chronic conditions, including premature death, very low blood glucose means we may lose consciousness and die. Even though in most cases diabetes involve insufficient insulin secretion or insulin-sensitive tissue becoming insulin insensitive, many variants of diabetes exist. In fact, there have been identified as many as 50 variants of the disease. The better known types of diabetes are called gestational diabetes and maturity onset diabetes of the young. And although these types of diabetes are less known than type 1 and type 2 diabetes, they still affect millions of people around the globe.